Hello everyone, welcome back to Educlynk. So we're going to do the correction of exercise 1. So let me read the exercise 1 again. So exercise 1 goes thus. An ideal mixture was made by mixing 3.2 grams of methanol and 4.6 grams of ethanol. The pure pressure of methanol and ethanol are 800 kilopascal and 400 kilopascal respectively. Full stop. Calculate the mole fraction of each component. B. The partial pressure. C. The total pressure. In this case, we're dealing with methanol and ethanol, so we have to give their structural formula. So I'll say let methanol be A and ethanol be B. So I'm just letting it. So let ethanol be A, methanol be B, where A and B are just the letters and variables. So we'll start by calculating the molar masses of each of the component in the mixture. So let's calculate the molar mass or the number of moles even. So Na is given mass all over the molar mass. Nb is also given mass all over the molar mass. So molar mass of ethanol equals to carbon is 12 plus hydrogen is 1 times 3, 3. Oxygen having 16, hydrogen 1. Molar mass of methanol is 32 grams per mole. So what do you have the molar mass of methanol? So we have to calculate the molar mass of ethanol also. So molar mass of ethanol is CH3, CH2, OH equals to 12 plus 3 plus 12 plus 2 plus 16 plus 1, which gives us 46 grams per mole. Having 46 grams per mole. So we have the various molar masses. We calculate now the number of moles. What do we do? Number of moles is given mass over the molar mass. So our given mass for methanol is 3.2 divided by 32. Number of mole of A equals to 0.1 mole. Nb is also, the given mass is 4.6, molar mass 46, number of mole 0.1 mole. We have done the greatest portion of the work. I've calculated the number of moles. After calculating the number of moles, we'll go now to calculate the mole fraction. The mole fraction of A, so I am on A. Na is equals to number of mole of A divided by the total number of moles. The total number of moles is simply 0.1 plus 0.1, which is 0.2. So the number of mole of A equals to 0.1 divided by 0.2. Because 0.2 is the total. How do I calculate the total? The total is simply 0.1 plus 0.1 gives 0.2. So having 0.1 divided by 0.2, which is 0.5. So having Na, which gives us 0.5. So here not N, is X. XA, XA, XA. XA is 0.5. Now I will use the other method. In the course of our lesson, I told you that XA plus XB gives 1. So if you have XA, you can make XB the sum of the formula. So what do we know? But XA plus XB gives 1. So XB is equals to 1 minus XA, which is 1 minus 0.5, which also gives 0.5. So that's XB. So XA is 0.5, XB is also 0.5. We're done with the first part of the equation. The second part is telling us to calculate the partial pressure. So what is the physical significance of partial pressure? The partial pressure is simply the mole fraction calculated times the pure pressure. Huh? So let's go to B. So B is XA is PA. PA is XA times P theta of A. P theta here stands for the what? The pure pressure. Now, what is the pure pressure of methanol? It has been given to us in the equation. That's 800 kilopascal. So it's going to be 800 times 0.5 times 800, which equals 400 kilopascal. Then PB equals to XB times P theta of B. So we need to know also have the pure pressure of B be given. The pure pressure is also given as 400. So you get to be what? 0.5 times 400 kilopascal, which will give us 200 kilopascal. C is telling us to calculate the total. P total is PA plus PB. So if you add 400 plus 200, it gives us 600. So P total is equals to 600 kilopascal. I think that's all about exercise 1. Exercise 1 goes thus. A was first of all calculate the mole fraction. Yeah, the mole fraction calculated. B is calculate the partial pressures. Having partial pressure of A, having partial pressure of B. Then lastly, C is telling us to calculate the total pressure. So the total pressure is PA plus PB. What's PA? PA is 400. PB is 200. So it's 400 plus 200 give 600 kilopascal. So in a nutshell, that's what we're supposed to do. Calculate the mole fraction. After calculating the mole fraction, calculate the partial pressure. After calculating the partial pressure, calculate the total pressure. So I think that is all about exercise 1. So welcome. Thank you for watching and follow me on Educlynk for exercise 2 and the correction. Thank you.